Topic 14, pressure. Part 2, fluid pressure. A fluid can be a gas or liquid. We are living in a fluid at the moment, which is the air surrounding us, of course. Fluids are able to flow or move around. Pressure formula. First of all, air pressure is lower up on the mountains than at sea level. Water pressure is much lower at the surface than deep down. So pressure depends on the fluid density and depth. And here's a formula. Pressure equal to rho is density times G, which is 10 times the depth or the height. These two pictures clearly illustrate that the deeper you go down into the water, the greater is the water pressure. Same with that one there. Why is water reservoir installed at a height? I think the answer is obvious. By using the formula for fluid pressure, we can calculate approximately how high the Earth's atmosphere is. How do we measure air pressure? We can find atmospheric pressure of our atmosphere by comparing the column of air, which is the height of the atmosphere, that creates our air pressure, with a column of another fluid. This is the old-fashioned mercury barometer. Here's a column of mercury, and here's mercury reservoir. We don't use this anymore because mercury vapor is harmful to health. Anyhow, here it says the barometer. The air pressure pushes down on the mercury reservoir, which is here, raising the height of the mercury up the tube, pushing mercury up this tube here. Once the pressure at the bottom of the mercury column, which is here, matches the air pressure there, it will stop rising. And so the mercury pressure will counterbalance the air pressure. What will the height of the mercury column be if it was in standard atmospheric pressure, given this as a density of mercury? Try it using this formula here. The height h, which is that one here, will give an indication of the atmospheric pressure. PA, pressure A here, is the atmospheric pressure because air is pushing down on here. PB, pressure B, is the mercury pressure. The mercury above it pushes down on it. And PA is equal to PB because they are at the same level. Pressure depends on depth, not on shape. All these containers are the same height. Therefore, the pressure at the bottom of each, due to the fluid inside the container, is the same. The shape matters not. This apparatus in the shape of an U is called manometer. It can be used to measure the pressure of a gas. Here we have a tank of gas connected to this end of the manometer. So the pressure of the gas in the tank is being measured. And this blue bit is liquid of density rho. Explanations for the manometer on the previous slide. P1 is the gas pressure, P4 is the air pressure, P3 and P1 at the same height, so the pressure is the same. P2 is at the very bottom, so it's the greatest pressure due to greatest height. And I add in here PL is the pressure from the column of liquid, the blue liquid, and it's equal to rho GH. So the gas pressure, which is P1, is equal to the air pressure plus on top the liquid pressure, which is rho GH. So you can just read off the height of the liquid column times G, which is 10, times the density of the liquid. You can work out what gas pressure is. Here is an example of manometer worked out for you. Here I use water for the liquid, the density of water is 1,000 kg per cubic meter. And let's say the height of the column of water is 40 centimeters or 0.4 meter. Then we can work out the fluid pressure from the column of water using this formula rho GH, and it works out to be 4,000 pascals. And the gas pressure is equal to air pressure plus the liquid pressure or the water pressure. Standard air pressure is 100,000 pascals plus on top 4,000 pascals from the water. Altogether is 104,000 pascals. Or express it in standard form, 1.04 times 10 to the power 5 pascals. This is a hydraulic press for lifting something heavy by using a small force. So what we got here is a small force F1 is applied over this area A1, and so pressure is created in this fluid, the oil, and this pressure is transmitted all the way to here. So the pressure in the oil is the same everywhere. The effect of the depth is negligible, and then we can work out the force applied here by the oil by using this formula here. F2 is equal to pressure created by this force here by using this formula times the A2, this area here. Now because this A2 is much bigger than this A1 here, so F2 will be much bigger than F1. These are some interesting exam questions you can read through yourself. Question 1 and 2, questions 3 and 4 on the next slide. Questions 3 and 4 here, read through yourself.